Hello guys, hope you're doing well. Today we'll continue our classes about circles and its properties. Okay, before continuing the topic, let's do some recap about the circles and its properties. We said that we can define a circle by its standard form equation. So each circle, we can write this circle as a standard equation x minus h squared plus y minus k squared equals the radius squared. If we have this equation, if we have this standard form of the equation, we can say that h and k represent the circles, the center of this circle, while r represent the radius of this circle. So we call this the standard form of a circle. But normally in SAT questions we don't have this standard form of the equation, so we have to find the standard form of the equation because you cannot find the radius and the center of the circle unless you have the standard form. So the question maybe could be like, if you have this equation right here, so it's saying you have this equation representing a circle, so try to find me the radius and the center of this equation. So basically what you have to do is you have to transfer this into the standard form of the equation, and we said that we have to arrange these terms and reorder them, and we have to do the perfect squared for the x's and y's, and then we can find the standard form, and we did some exercises. We also said that if we have a line and this line is perpendicular to the radius of this circle at one of the end points of the circle, we can say that this line is a tangent line to this circle or at this circle. So in this case we have to find the equation of this line, and we know that the general equation of any line, we can write this as y minus y1 equals mx minus x1, or we can write the normal standard form, which is mx plus b, and b is the y-intercept. So how to find the equation of this tangent? We said that we have to find the slope of this radius by 2 points, because we have the 2 points, and then we can find the slope of this tangent line because it's a perpendicular line. So basically what we have to do is taking the m, multiplying by negative, and find the reciprocal of this m. That's how we find the equation of the tangent to a circle. And we said that we have some properties of this tangent. So if we have one external point and we have two tangents, we would say that these two tangents are equal in length. So we can use this to find one of the properties of the circle. So guys, these are the properties we were speaking about during the last two classes, or three classes. We will continue speaking about the new properties of the circle. Okay, let's try to look at this new definition. We can define the area of a sector, which is a fraction of the circle containing the sector of this circle. Example, look at this circle in this diagram. So we can notice that we have this sector between these two radius. So AC is a radius and CB is another radius. So basically he's asking me to find the area of this colored, of this shaded sector. So how to find this? Guys, by definition we can define this angle, which is ACB. Let's call this angle M. The measure of this angle is M. So I can define the area of this sector equals to PR squared, which is the area of the full circle, multiplied by M, which is the angle, over 360. Why 360? Because the full circle is 360. So as if I'm taking a fraction, as we said, of the whole area of the circle and dividing this by 360. So again, to find the area of this sector, we take the full area of a circle, which is PR squared, multiplied by m, which is the measure of this angle, over 360. Maybe someone will ask me, can I use instead of the degrees in this angle, can I use the radian? Yes, you can. So instead of having this angle measured in degree, if it's in radian, so instead of 360, we will use 2 pi, because the full angle of a circle is 2 pi radian, or I can use 360. So it's up to you guys. If the question is in degrees, you can use degrees. If it's in radian, you can use radian. So to find again the area of one of these sectors, you can just take the full circle area multiplied by the fraction, which is the angle over 360. Let's take an example. Okay guys, take a look at this example. He's saying we have this circle and the radius of this circle is 12 meter, and the angle between these two radius or radii is 131. So it's asking me to find the area of this sector HGJ. So basically what we have to do is to find the area of a circle, which is PR squared by R squared, and then we have to take this angle because it's in degrees over 360. So how to solve this? First of all, the area of a sector equals, we use the formula PR squared m 360. So R in this case is 12, so instead of R we have 12 squared, m 131 over 360. So it's asking me to keep pi because we don't have to calculate pi, it's up to you guys. So you have to find the area of this sector. So guys, we have to pay attention to this case. Pi in this case 3.14. It's not the pi of the angle, it's the pi which is the arithmetic pi. So to find the area we have to, if you want to plug instead of pi a number, you have to plug 3.14. Okay, so this is how we find the area of a sector, by just doing or using this formula. Okay guys, another example to find the sector of this, the area of the sector in here. So R equals 5 in this example, while the angle equals 25. Guys, by the way, we call this angle central angle because it's an angle between the center and two radii or two radius. So the angle is 25 and the radius is 5, so we can use the formula to find the area of the sector. Again, as we did before, A equals pi squared m 360, so just plug R5 and m 25, you can find the area of a sector. In such question, yes, we do have such questions. You have one of the options could be the area of one of these sectors. So basically you need two things. You need the area of the circle, which is R, and you need the central angle, which is in this case 25. Hope you enjoyed the class guys. Thank you so much.